Okay, welcome. My name is Mayur, and I'm gonna use RapidMiner to build some models to find out if we can predict some valuable things from the dataset that I have, which is completely based on coffee trends in India. Let's go on. So about the dataset, this dataset shows various attributes regarding the coffee consumptions in India, which has like three numeric attributes, and the others are categorical, which include milk preferences, sugar preferences, awareness of specialty coffees, and so on, etc. So let's go on. So for the data cleaning part, we didn't have to do much of things because it was already a clean data set. That was a good part for me. So I directly moved on for data pre-processing, in which I selected relevant attributes those I thought would contribute in model building, and then I used the nominal to numeric operator to convert the categorical data into numeric, and then by setting roles, I selected daily cups consumed as the label, and I also used normalize operator to normalize the entire data. Next on, moving directly up to building a model. Firstly, I gave a try for a regression model, for which I split data into 70-30 and used 70% of it for training and 30% for the testing part. As you can see this thing here on my screen, it's split data, use the operator for linear regression, connect the model port to apply model, and then also get the 30% testing data from split data directly into the apply model part. And then I connected the apply model operator to performance operator, which will be used for evaluating the performance of the model that we're building. And the other part, the model part for apply model, I directly connected it to the results port. Then getting on the performance operator, I also did it for performance port and the example port, which I connected directly to the results. And after running the model, we see the results now. So there's a labeled data about daily cups consumed. So we can see that almost every prediction is not accurate. So it's being not even a single one I see is correct or as it is as the value that we already have. But still, the model has given some or the other predictions on that. Let's see on the performance thing. Okay, so this is the regression tab of the results. We can see the p-values and the code star codes for our attributes, those were relevant. So the preferred coffee, like the coffee brands, contribute tremendously in finding that which one is relevant for the model building. So all of those below 0.05 p-values are a great choice for going forward with. So after looking at this, we can conclude maybe the data set is not that great to build a model on, but still now that we have got started with it, let's move forward and let's see it how it's gonna go. So the performance vector, the performance tab for the regression model. So we see all our values here, like even the RMSE, the squared error, the correlation, squared correlations. All of these values are not that great. Leave about great, but I would say these are bad. So we have failed in this model. So yeah, let's just move on to the next one and try to build a decision tree model. So I've just replaced the linear regression operator with the decision tree and connected the ports as earlier. The rest of the things are all same. And now for the result part, we see like all the predictions are one value itself, like be it any row, or any example, the prediction value is the same, that is 3.017. So there's definitely wrong in this model here itself. So I don't know what the data set is on. I've tried working a lot on this, but I don't know. Still, let's see on the performance vector. So even these values are bad, not good to move on with. We'll disregard this model and try going with the random forest. Let's see. Just replace the model operator to random forest. Rest all is the same. Let's go on to the next slide and see about the results for this model. So we have different kinds of values for the prediction, but still it's kind of similar to the regression model that we saw, and there's no matching value at all. So maybe there's some concerns here again, similar to what we saw in regression. So the performance vector here is these values even does not look great. So to the conclusion, so it's all about, you see, the data set that we have, and which I don't think so is that good. So my major challenge for this what we say, the final project or model building part is I did not go good with the dataset selection, and that has costed me here. But still, valuing the time and analyzing what I have in my hands, I tried doing so. This is where we got so far. Uh, so, what if we had a good dataset? We would have built great predictions, great models. So, for example, if it was about more of numerical attributes instead of categorical attributes. So, here we just had three numeric attributes. So that was the main part here. Instead of so many other categorical attributes, we could have like got on to a data set which had like many of numeric attributes in it already. So that's the point. I think maybe we could have got a good thing on. But no worries. So we'll keep that in mind, and you guys also, when you try to build a model on and RapidMiner, make sure like you have a data set which is good with great values, relevant attributes, I would say, and most of those are numeric. It is good to have categorical attributes as well. So it depends. Like if it's a classification case, you need a categorical attribute. But whatever your goal is, try to see like what model you're trying to build. According to that, you should get a data set and analyze what kind of things you need to find out. So accordingly, you need to analyze the data set like, okay, these many should be, or at least such should be my numeric attribute to quota or categorical attributes quota. So that's all for now. We'll keep in mind for these things that I said now, and all the best for your model building. Thank you.